Okay, good day. So today we are looking at the work that I've given you guys. Now, in the diagram below, O is the center of the circle and point T lies on the chord RS. Prove the theorem which states that if OT is perpendicular to RTS, then RT is equal to TS, meaning to say you want to prove that these two sides, this distance is equal to this distance, isn't it? So what you do, you construct OR, then you also construct OS. Now, what we have now is that what you're trying to prove here is that you are trying to prove that OT, ORT, and OST are congruent, meaning to say they are identical. So that's what you're trying to prove here. When you are trying to prove RT is equal to TS. So your goal is to prove that the triangle, those two triangles are congruent. How do you prove that now? You see that you've got 90 degrees already, so you must prove the right angle, hypotenuse, and the sine. Now, so what we have here is that we're going to say OR is equals to OS, is equals to OS. Why are we saying this? Because they are both what? Radius are equal. So both of them, they are radius, and we from the center there, so they are equal. Then the other side is OT is equals to OT. This is common. It's common for them, OT. And now what we see is that OTR is equals to OTS is equals to 90. And what is the reason here? Straight line. Angles, what? Straight line is equals to what? 180. We are already given that this is 90, so the other one should be also 90. That's what we have there. Therefore, what we have there, therefore, ORT is congruent to OST, the triangle. So in this way now, we are going to say RT is therefore equal to TS. Why are we saying this? They are congruent. Is right angle HS, which is the hypotenuse and one side. That's what we have there. That's the reason there. Okay. Then in finally, we actually prove that they are equal. So that's what you're supposed to do, guys. You actually proving that the two triangles are congruent. Now let's move on to the next chapter here. What we have next question in the diagram. O is the center. O is the center of the circle ABD. Now, ABD, this is a circle. F is a point on chord. F is a point on chord AB, such that DOF, where is DOF? DOF is perpendicular to AB. It forms 90 there. AB is equal to FD. So FD and AB, they are equal to 8 centimeters. Then OF is equal to X. So now we are given there. Now you are asked to prove that determine the length of the radius of the circle. So you're actually trying to find length of OB. Length of OB. That's what you're trying to prove there. So what do we know here? We know that AF is equals to what? FB is equals to 4 units. So 4 centimeters in this case. What is the reason there? Because we know that angle, so tan chord. So here we've got, we have got a line from the center, bisect what called the chord. So here, line, center, bisect, chord. That's what we have the reason there, okay? So we know that this one should be our 4 centimeters there. This is also 4 centimeters. But we also want to find OB. What is OB? We know that OD is equals to FG minus FO, which is going to be, because FD is 8 minus X. That's what we have there. So that's our OD. So that's how we get OD. And OD is equals to what? OB. Because they are both radius. Radius are equal. Now, what do we need to do now? We get this one, 8 minus X. So we are looking for what? We are looking for X. So what are we going to do? We're going to form an equation there. We know that hypotenuse squared is equals to what we call X squared. So we're going to say 8 minus X squared is going to be equals to X squared plus 4 squared. So here it's going to be 64 minus 8 times negative is going to be minus 16x. Was going to say 8 times negative x, we get negative 8x times 2, negative 16x. Then plus x squared is equal to x squared plus 4, which is, 4 squared is 16, okay? Then what are we going to do now? We're going to bring this x, that side is going to cancel. So x and x will cancel there. Then we're left with what? We'll take the negative 16 there. It's going to be 16x is going to be equal to what do we have? 64 minus 16. 64 minus 16, we get 48. So 48. Then x is going to be equal to 48 divided by 16, we get 3. So x is equals to 3. But we haven't found our answer yet. We know that OB is equals to 8 minus x, which is going to be equals to 8 minus 3, which is equals to 5 centimeters. Done. That's what you're supposed to do there. That's what you're supposed to do there. Okay, this is our last there. This is our last. So from there, we come down here. Okay, now let's move on to the next question. What is it saying? It's saying M is the center of the circle SVQR, having chords SV and QR, and OP, RP and OP are tangent to the second. So it means that these two are equal. Always remember, tangents from the same point, they are equal. Then, so it means the base angles, they are also equal there. Okay, we haven't found that. We haven't asked any questions here, but we're just trying to conclude what we can see. Now, here, what do we have here? R and Q respectively, such that, sorry, man, RP and they are tangents to the second at R and Q respectively, such that RPQ is equal to 70. So here is our 70. Now, the first question is saying, calculate the size of R2. Where is R2? Here is our R2. Now, our R2 there, how would we get our R2? We know that we already know that this is equal to this. So what do we do now to get our R2? We know that this is 10.1. Our R2, we're going to say R2 is equals to Q2. Why? Because of tangents from same point. They are equal. Okay. Now we're going to say now 180. So R2 is therefore equal to 180 minus 70 divided by 2, which is going to be equal to 110 divided by 2, which will get 55. So 55 degrees like that. Now calculate the size of Q1. Q1, where is Q1? This is our Q1. But now we know that PQ, Q1 plus Q2 is equals to 90, which is 10.2. These two are equal to 90. Why are we saying that? We know that tan change is perpendicular to the what? To the radius. Okay. Then what do we have here? We're going to say Q1, what we're looking for. Q2, we already have it. So Q1 is going to be equals to 90 minus what is our what is it? What is our Q2 is 55. Because we already know that Q2 is equals to R2. Okay. So here, what are we going to get? We are going to get what? 90 minus 55, we get 35. Okay, determine the size of M2, 10.3. M2, where is our M2? M2 is here. And how do we get our M2 now? How would we get our M2? How would we get the M2 there? Oh, sorry, here is our M2. And our M2, we are going to say what? We have got 35, and we are saying our, let me see here, we can't use the exterior angle, we can't do that. So what are we going to do here? We know that this is 35, okay? So what else do we know there? So 35, so we know that M1 plus R1 plus Q1 should give us 180. We know that that's sum of what you call sum of, what is it? Sum of angles of a what? Of a triangle, add up to 180. Now, what is our M1 now? We know that this one, we already have them. This is 35 plus 35 is going to be 70. So M1 should be equals to 180 minus 70, which is equals to 110. Okay. Now, M1 is 110, and we are now saying M1 is equals to M2. Why? Because they are equal chords, subtend, equal angles at the center. So equal chords, they do subtend same angle. So therefore, M2 is going to be equal to 110 as well. Okay, that's what we have there. Equal chords. Once you have got equal chords here, you know that equal chords subtend same angle. Even on it subtend same angle on the circumference, on the center, and also on the circumference. So if they are equal chords, wherever they're subtending their angle, either at the center or in the circumference, the angles should be actually equal. Okay, once you see equal chords, remember that. Now let's go to the next question here. In the diagram below, O is the center of the circle. Okay, now we're told that CDE is a tangent to the circle at D. CDE is a tangent to the circle at D. DB bisect ABC. DB bisect ABC, meaning to say here we are bisecting this angle here. When you are bisecting means you are dividing into half. Now, let B1 equal to X. So once we have got X here, it also gives us this one as our X as well, because we are told that it's bisected. So those are the things that you must conclude, guys, from the statement before you actually go into what into answering the questions. Okay. Now, prove that BC is parallel to OD. BC is parallel to OD. Now, when you are proving parallel lines, you must think of find what you call alternate angles that should be equal. You are just going to prove that alternate angles are equal. Then you're trying also to prove that the corresponding angles are equal, or co-interior angles that add up to 180. So whichever way you try to find, that's not a problem. Now, how do you do that? Now we see that this one here is our alternate angle that we can get when we are to prove that this is parallel to that. The alternate angle will be B2 and D1. So are those two equal? We need to do that using our the other way. Now, so we have got 11.1. Now let's see how we're going to prove that. We know that here, from what we have here, is that we have our B1, which is equal to B2, which is equals to X. Why is it that? Because B angle O, sorry, DB bisect B. Okay, DB is bisecting B. Now we have got X and X there. Okay, so what else do we see that? We see that O D1 is equals to X. Y is equal to X because is equals to B1. So we're going to say is equals to, let me just check here, is equals to B1 is equals to X. Why is it that? Equal, so we are saying OD, OB is equal to what? Is equals to OD because they are both what? Radii. So the radius should be equal. That's what you're saying here. So you're saying these two are radiuses. So the base angles should be equal. Isosceles, base angles should be what? Should be equal. So that's what you're saying that. But now once we have got D1, D1, so it means that B2 is equal to what? D1. And what does it tell us now when those two are equal to? They're equal to X. It means that those are alternate what? Alternate angles. Those are alternate angles. So once they are equal, we can now say the alternate angles that should be also equal because they form a Z angle. So we have proved that D1 is X. So we already proved that the alternate angles, they are actually equal in that case. So let's see that 11.2. Okay. We want to prove that C is what? Is 90. Now, when you want to prove C is 90, what are you going to do? Again, now you are carrying. Remember, you carry whatever information that you have from previous. They already told you that these two, so you are treating them now as parallel lines. You are treating them as parallel lines. So what you see here in this one here, we can now say that, okay, our D, or we can say E, D, O, E, D, O is equal to 90. Now, if it is equal to 90, why are we saying it's equal to 90? Because this is a tangent, tangent is perpendicular to the radius. That's what we know. So once we have that, we know that OD should be equals to C, should be equals to 90. Why are we saying that? Because these are what we call corresponding angles. Are equal. Corresponding angles. Remember, when you have got this angle here and this angle, they are corresponding if these two lines are parallel. Okay. So that's what you're saying here. So the corresponding angles, they should be actually equal. Okay. That's what we're talking about there. So here you can also use D1 and D2, which should give you 90. And when you say 90, it means that here is going to also be 90 because when you add the two, they must give you what? They must give you 180. Okay. So that's what we have there. So let's move on to the last part there, the last question. It's a bit long. Yeah. Just trying to fold this so that you can have enough space here. Okay, that's what we have there. Now, what we are going to do now is that we have our circle, two circles. So in the diagram below, two circles touch. Okay, we know that we are saying here in the diagram below, two circles touch each other externally at point P here. Okay, then QPR is a common tangent. QPR is a common, so this is our PQR is a common tangent to both circles, this circle and the other circle. Then EDRC is a tangent to circle PB, which is this circle here at C. RCA is Y. RCA is Y. RCA is Y. That's what we have here. And the DAC is X. DAC is X. Then also I told that AD are parallel to BC. What I always tell you guys that when you see parallel lines, think of look for alternate angles, look for corresponding angles, look for co-interior angles. Those are the things that you must also look for. They can't just give you parallel lines, okay? So you must always look into that. Now, let's check here what we're having here. We are saying name with reasons 4 other angles equal to x. Now, here's the question here. 4 other angles equal to x. We are going to say, okay, 12.1. Okay, 12.1. What do we see there? We see that if we are to check here, I'm just going to show you something here. If we are to put our circle like this, so remember you can tilt the way you want so that you can everything can be visible there. What I can see here before I look into parallels, I can see that what I have here is that we have got same chord here subtending 2 angles here. So we have the angles in the same segment here. So we have got x here as well. So let's start with what is it? With E. So E, so A 1 is equals to E is equals to what? X. So it's actually, should I say E is equal to X? I should have said equal to A1 is equals to X. So what are we saying here? Angles in same segment. That's what we're saying here, okay? Then that's the first angle. What about the second angle? Let's also look in terms of parallels. We are seeing that this is a Z angle. So C2 is equals to A1 is equals to also X, Y alternate angles are equal. So alternate angles are equal. What else can we have again as our what is it? As equal here? We see that here we have a tangent here. We have a tangent here that is QPR, and what we see that is P1 here. P1 should also be equal to what? Should be also equal to A1, should be equal to X. Why are we saying that is tan chord? Now, because tan chord here, the chord is subtending the angle there. Then what is the, we've got 1, 2, 3. What is the fourth angle there that is equal? That is equal to X. Let's check what is equal to X. Now, P1 and P5. P1 and P5. So P5 is equals to P1. This Y is equal to X. Why are we saying that? Opposite, vertically, opposite angles are equal. Vertical opposite angles are equal because what we see here is that we have got this line here that goes there, and with these two are actually equal because they are vertically opposite. Now, what else there? We've got 4 angles now. 1, 2, 3, 4. We are left with, oh, we are done. We have already answered the question. Now let's move on to the next question. It's saying show that EPA is equals to X plus Y. Now this is 12.2. Show that EPA is equals to X plus Y. EPA, where is EPA? We need to find the what is it? The angle first. EPA is equals to X plus Y. Okay, now we want to find that. So what are we going to do now? What are we going to do now? What are we going to do now? What are we going to do? We see that. All right, can I see something here? We have, we're looking for EPA, this one here, which should be equals to 1, okay? But what can we see here? We see that, can you check something here when you look at the parallels here? The parallels AD and BC, we see that this angle here should be equal to this whole angle here. Now we know that C is equals to, angle C is equals to X plus Y. Or should I write first like this? This one should be equals to C1 plus C2, which is equals to Y plus X. That's what we have there, because we already found this one is an alternate angle. Okay, now we already found that C2 here is X and C1 is given is actually Y. Now what do we do now? We know that D1 should be equals to what? Should be equals to C, which is should be equals to x plus y. Why are we saying that these are corresponding angles? They should be equal. Corresponding angles are equal. Now, from there, now what do we do now? We are looking for what? We are looking for, we want to find what? EPA. Now we know that EPA is equals to D1. Okay? Why is it equal to D1 is equal to also x plus y. Why is it like that? Because they are angles in the same segment. Now you need to do this now with the triangle, with the second. You see that this angle here and this angle here, they are in the same segment. So they are subtended by the code AE. So AE is subtending angle here, subtending angle here. So we are saying angle in the same segment, they are actually equal. So we have proved that EPA is equal to x plus y. Now, so when you are given this, you play with it, tilt it the way you want, so that you can actually see what is hidden. Now, we are now asked to find 12.3. We are asked to find the numerical value, determine the numerical value of x plus y if it is given that DCTP is a cyclic quad. Now, DCPE is a cyclic quad, meaning to say DCTP is a cyclic quad, meaning to say here, when we have got this angle here, so we're going to play with angles that we have got more information for, because we can't deal with this angle here. Cyclic quad, when you're doing cyclic quad, you deal with exterior angle, or you can work with what is it, opposite angles, which should add up to 180. So you must work with that. Now, that property, now let's see here, we have got the P1 plus P2 plus P3 must give us what? Must give us, when we say P1, so P1, we already have it, is equal to X. And P2, do we have P2 there? Do we have P2? Okay, let's check here. Let's play here. P1 plus P2 plus P3. Okay. What do we find there when we deal with those? Let's check here. Let's check what we can find. Okay. So if we add this 2 plus C, so these angles here plus C must give us 180. Now we are saying opposite angles of what? Cyclic quad. So that's the property that we're going to deal with now, so that we can get to our answer. So we know that these two here, if we add them, we get what? We get what called 180. So we're going to say now, what is our P1? We already have it. P2 should be equals to what? P2, let's check P2 here. P2, we see that P2 should be equals to C1, is equal to C1. Why are we saying that? Because we have got the tangents from the same point. Tangent from the same point. The tangent, which is the RPQ and also RC. These are two tangents and they are meeting at R, and they should give us what we call, they are equal. These two are equal. Okay, when they are equal, the base angles should also be equal. So we are saying tangents from same point. So equal to Y here. So P2 is equal to C1 is equal to Y, tangent from same point. That's what we are saying here. Tangent from same point, they are equal. Okay. Tangent from some point, they are equal. Now, what are we having? P1, we already have it, which is X. And P3, we have P3. P3 is equals to P7. Is equal to P7. Is equals to what? Is equal to what is it? We already found it as X plus 1. P7, which is this equal to this, because X plus Y. Why are we saying that these two are equal? Vertically opposite angles. Vertical opposite angles are equal. Now, that's what we have there. Then now, when we have that, what are we going to do now? C, we already have it. C is x plus 1. So now we're going to say now, we are already putting everything now together. We're going to say your P1, which is x, plus your P2, which is y. P2, we find that is y, plus your P3, which is x plus y, plus your C, which is equal to what? Your C, which is equal to your C1 plus C2, which is equal to x plus y as well. X plus y should give us 180 because opposite angles of a cyclic quad. Now, x plus x plus x, we get 3x. Y plus y, we get 3y is equals to 180. Then we factor out 3x plus y is equals to 180. Then we divide by 3 both sides. If we divide by 3, I think we should get 60. 180 divided by 3, we get 60. So x plus y should be equals to 60 degrees. So you have found the numerical value of x plus y. So that's how we get x plus y. Okay. So I think this is the end of the work that I have given you guys. I hope you understand. Okay. Thank you so much.